Hello boys and girls, welcome to Mrs. Bandu's Math Movies. This is Lesson 6.3 for Algebra, Applying Linear Functions. So what we'll be doing in this section is interpreting linear graphs. Alright, so we'll start off with this problem. In the aftermath of a hurricane, a tent city houses 1,045 refugees. They are to be moved by bus to better accommodations. Each bus can carry 55 passengers. Assuming that every bus departs with a full load, write a linear function that relates the number of bus loads already departed to the number still remaining at the tent city. Graph the function that models the situation. Okay, so this is what we want to relate here. The remaining refugees is equal to the number of total refugees of 1,045 minus some number times 55 passengers per bus. Okay, so to find the total number of refugees remaining depends on the total number of bus loads departed. So the number of refugees remaining is the dependent variable, and the number of bus loads departed is the independent variable. So X is the number of departed bus loads. Y is the number of remaining refugees. So Y is equal to 1,045 minus 55 times X. The domain is the whole numbers 0 through 19 because the number of refugees remaining cannot be negative or cannot fall below 0 if you want to think of it that way. Okay. So that's just kind of understanding what this is telling you. And here you have a graph to represent that situation. Each dot represents a bus that has departed and how many refugees remain as well. Okay, so when it gets to bus number 18, that should pick everybody up. Everybody should be gone then. Okay. All right, you have a quick check to go to do a similar type situation. Also be sure that you graph the function that models this. Have that ready to go. Let's look at the engineering question. One factor in the ability of soil to support the weight of a man-made structure is the amount of water below the soil surface. The graph illustrates the changing water table in an urban area due to water being pumped from drilled wells. The present time is designated as t equals 0. Okay, and A, what do the slope and the y-intercept mean for the given situation? The slope is negative 2/3, and I found that simply by locating 2 points on the line that are at corners of boxes so that I could actually count. So my slope from this point to this point is down 2, right 3. So that's 2/3, or negative 2/3, excuse me. This means that the water level is falling at a rate of 2/3 inches per year. The y-intercept is 16. This means that the present level is 16 inches above the minimum. If the graph had the same slope but a y-intercept of 26, what could you conclude about the water table? Well, I would be able to conclude that the water table was 26 inches above the minimum. If the graph had a slope of negative 4.5 inches per year, what could you conclude about the water table? Okay, that would tell me that the water table, or the water level, was falling at a rate of 4.5 inches per year. So actually it would be a much steeper slope. It would be falling much faster. That's what that would tell me. Okay. You have a second quick check to go with this. Have these ready for discussion, and basically this is what we'll be doing. We'll be taking graphs and information and interpreting what they tell us in this section. So come in with any questions you might have, and we will go from there.